terraforming Mars may no longer be science fiction. Scientists say it's becoming a real possibility. Source: Universe Today. Green Mars Workshop Summary, 2025. For more than a century, the idea of terraforming Mars has captured the human imagination. Science fiction has long envisioned a future where the barren red planet is transformed into a second Earth, a world with blue skies, flowing rivers, forests, and cities where humans can live without bulky spacesuits. It has been a dream featured in novels, movies, and scientific speculation alike. But despite its popularity, most scientists dismiss the idea as wildly impractical. The technology simply didn't exist. The costs were unimaginable, and many believed it would remain impossible for thousands of years. That perception may now be changing. If you like my videos, subscribe my channel, and press the bell icon to turn notifications on so you keep getting all the major advancements in science and technology. And don't forget to like and share this video with your friends and colleagues. Comments are welcome and open for discussion. A growing number of researchers believe that terraforming Mars has moved from the realm of science fiction into a legitimate scientific question. No one is suggesting that humanity will begin reshaping Mars anytime soon. But thanks to rapid advances in space transportation, synthetic biology, climate science, and artificial intelligence, scientists now argue that the real debate is no longer can we, but rather should we? And how could we do it safely? The discussion was reignited during the 25 Green Mars Workshop, where researchers examined whether modern technology has fundamentally changed humanity's ability to transform another planet. The workshop's summary, written by Dr. Erica De Benedictis, CEO of Pioneer Labs, concludes that although terraforming remains an enormous challenge, it is no longer obviously impossible under the laws of physics. Instead, it deserves serious scientific investigation. But before we explore how scientists believe Mars could someday become habitable, we first need to understand what terraforming actually means. Terraforming is the process of changing the environment of another planet or moon so that it becomes capable of supporting life from Earth. That means altering its atmosphere, climate, temperature, and even its chemistry until humans, plants, and animals could eventually survive there. Mars has always been considered the most promising candidate. Unlike Venus, whose surface is hot enough to melt lead, or the frozen moons of the outer solar system, Mars already shares several similarities with Earth. A Martian day is only about 40 minutes longer than ours. It has seasons, polar ice caps, mountains, valleys, and evidence that rivers and lakes once existed billions of years ago. Yet, today's Mars is incredibly hostile. Its atmosphere is less than 1% as thick as Earth's, and is made mostly of carbon dioxide. Surface temperatures average around minus 60 degrees Celsius. Liquid water cannot remain stable for long because the atmospheric pressure is so low. Cosmic radiation constantly bombards the surface because Mars lacks a strong global magnetic field. Without protection, an unshielded astronaut would receive dangerous levels of radiation over time. Turning this frozen desert into a living world would require changing almost everything about the planet. Researchers believe the first challenge would be warming Mars. Fortunately, Mars may already possess one of the most important ingredients needed for transformation: vast amounts of frozen water. Scientists estimate that if all of Mars' underground ice and polar ice caps were melted, they could produce an ocean covering nearly 4 million square kilometers, with an average depth of approximately 300 meters. That's enough water to dramatically reshape the planet's surface. The problem is unlocking it. According to current climate models, raising Mars's average temperature by roughly 30 degrees Celsius could begin melting significant portions of these frozen reserves. The workshop proposes several possible ways of achieving this. One possibility involves releasing specially engineered greenhouse gases that trap heat far more effectively than carbon dioxide. Another idea uses microscopic aerosol particles designed to absorb sunlight and warm the atmosphere. Unlike conventional greenhouse gases, these engineered aerosols could potentially be optimized specifically for Martian conditions. The goal wouldn't be to make Mars warm overnight. Instead, researchers envision a gradual warming process taking several decades, slowly thickening the atmosphere while allowing liquid water to begin appearing on the surface. Of course, warming the planet alone wouldn't make it breathable. The next stage would involve something even more ambitious, introducing life itself. Scientists believe specially engineered microorganisms may play a critical role in the earliest stages of terraforming. These wouldn't be ordinary bacteria. Researchers propose designing extremophiles, microorganisms already capable of surviving Earth's harshest environments. Some naturally thrive in boiling hot springs. Others survive intense radiation. Some live inside Antarctic ice or deep underground without sunlight. Using advances in synthetic biology, scientists believe these traits could eventually be combined into entirely new organisms specifically adapted for Mars. Once temperatures become less hostile, these engineered microbes could spread across the planet in thin algae-like layers. Like plants on Earth, they would perform photosynthesis, slowly converting carbon dioxide into oxygen while producing organic material. This process would be incredibly slow. Researchers estimate that building a breathable atmosphere naturally could require hundreds or even thousands of years. That raises an obvious question. Where would the first human settlers live while waiting for the atmosphere to change? The proposed answer is massive enclosed habitats. Instead of attempting to terraform the entire planet immediately, future colonies could begin inside enormous transparent domes reaching roughly 100 meters in height. Inside these habitats, oxygen could be produced using water electrolysis or photosynthetic plants. Crops could grow under controlled conditions while scientists gradually expanded these protected ecosystems outward. Over generations, as more oxygen accumulated and more vegetation spread beyond the domes, Mars might slowly transition toward a more Earth-like environment, at least in theory. But researchers are careful to emphasize that enormous scientific uncertainties remain. We still know surprisingly little about what lies beneath Mars's surface. Scientists don't fully understand the structure of the planet's buried ice deposits. They don't know exactly how Martian dust storms would behave in a warmer climate. They also aren't certain whether Mars contains enough accessible minerals to support large-scale oxygen production through water electrolysis, or whether enormous quantities of materials would need to be transported from Earth. These aren't engineering details. They could determine whether terraforming is practical at all. And then there are the ethical questions. What if Mars already contains life? We see. No one has yet discovered living organisms on the red planet. But many scientists believe microbial life may still exist beneath the surface, protected from radiation inside underground aquifers or deep beneath layers of ice. If humanity introduced Earth organisms before thoroughly exploring Mars, we might unknowingly destroy an entirely independent branch of life before even discovering it. That would represent one of the greatest scientific losses in history. Terraforming could also erase billions of years of Martian geological history, permanently altering a planet that has remained largely unchanged since the early solar system. In other words, the question isn't simply whether humans have the ability to reshape another world, it's whether we have the right to do so. Interestingly, researchers argue that studying terraforming may benefit Earth, even if Mars is never transformed. Technologies designed for surviving on Mars could improve life here at home. Well, scientists working on drought-resistant crops, closed-loop recycling systems, efficient water purification, sustainable agriculture, renewable energy, and artificial ecosystems are already solving problems that also affect Earth's growing population. Now, wait. Many technologies originally developed for space exploration, from satellite communications to medical imaging, eventually found widespread use on Earth. Terraforming research may follow the same path. For now, scientists are not proposing giant planetary engineering projects. Instead, they recommend laboratory experiments, improved climate simulations, advances in synthetic biology, and carefully controlled demonstrations during future robotic Mars missions. The goal isn't to begin changing Mars tomorrow. The goal is to understand whether such a transformation could ever be achieved responsibly. Perhaps the most remarkable change isn't technological at all. It's philosophical. For decades, scientists asked whether terraforming Mars was physically possible. Today, many believe that question has largely been answered. It appears that nothing in the known laws of physics absolutely forbids it. The much harder questions now are ethical, environmental, economic, and biological. Should humanity transform another planet? Could we do so without destroying something precious? And if we eventually become a civilization living on multiple worlds, what responsibility will we have toward the planets we choose to reshape? Those questions may define not only the future of Mars, but the future of humanity itself.